Hello everyone. First and foremost, thanks for coming here. Hi Tomek. Przemek, I'm sorry. I would like to say a big thank you for the organizers because that's my hometown. I spent 18 years in Bydgoszcz, so it's my pleasure to be here. I'm honored to speak near Myślęcinek, where as a teenager I did a lot of stupid things. So thanks for coming. I know you had plenty of options on this lovely Friday, and I'm here to talk about how to refactor and how to do it safely, all right? A few words about myself. My name is Jakub Pilimon. I work as principal technologist at Pivotal and also as an independent consultant, and I work for Bottega IT Minds as a trainer. So these are my main areas of interest. I firmly believe in testing my code, so I believe in test-driven development, in domain-driven design. I like to talk about architecture in any form, and also I like to talk about Spring. So if you have any questions about Spring architecture, TDD or DDD, I'm here after the talk. I'm happy to discuss anything. I have a blog where I blog semi-occasionally, I would say, once a year maybe. And I have a pet project. It's called Domain-Driven Design by Examples. You can find it at GitHub. So if you would like to model some domain according to domain-driven design principles, guidelines, and rules, and then back it up with some framework like Spring in the infrastructure layer, give it a go. There's plenty of fun work to do together, so if you like to collaborate, just give us a note, and there's plenty of fun work to do. Let's start by sharing what this talk is not going to be about. So I'm not going to talk about those great two books. Have anyone read those books? Hands up. Great. So I tend to think as those books as they cover like local refactoring. So if you'd like to know how to extract method properly, how to extract functions, objects, etc., how to run your classes into a testing harness, these are great books. But they cover like a local refactoring. So for this talk, we are going to assume that we all know that there are good design practices, like there is test-driven development, there is object orientation, there is domain-driven design, there's actor model, there's functional programming, etc. But then, on Monday we come back to office and there is a reality. And we have to apply some knowledge in the real world. So instead, I'm going to talk about something which is called a bubble context. So Eric Evans, the father of DDD, described that as a bubble context. What bubble context is about? It's more or less an approach of dealing with legacy systems. So it requires you to create a fresh functionality, a fresh context for your functionality that is shielded from the legacy world and the entanglements of the legacy worlds. So we might call it a global refactoring or strategic refactoring when we change the entire model of some sort of our application, all right? Not local refactoring, but on the other hand, global refactoring. The technique I'm going to share, I have successfully applied with a couple of my clients in my previous life before Pivotal, when I was working as independent consultant, but it has some limitations, all right? So it's not like a silver bullet. It might have some limitations. It might be that in your context, in your organization, this technique is not suitable, and that's okay, that's fine. All right, how many of you have heard about something which is called big ball of mud? Hands up. How many of you would describe your current system a big ball of mud? Nice. All right, so there is one secret about big ball of mud. It's not mud. And the different secret is that I would say it is an architectural pattern. People call it an anti-pattern, but in fact it is a pattern in which you don't follow any guidance, any principles, any rules or whatsoever, and you just let the code grow together and somehow just stick it so that it works at the end, right? So we tend to feel that big ball of mud is just bad, right? We say that big ball of mud is bad, we shouldn't be doing that, but I have a feeling that this feeling of something being bad, it has to be contextualized. Like, why is it bad? Why is it bad in my organization? Why it causes problems, or does it cause problems, etc. Just saying something is bad is not enough, in my humble opinion. We have to justify something being bad. It's like saying Java is bad, or I don't know, PHP is bad. That one might be easy, but we have to justify this feeling of something being bad. So we tend to say that big ball of mud doesn't have any structure, it's sloppy, and it feels like duct tape style code, right? Again, these are just subjective opinions. So we have to go deeper and deeper and deeper. And we talk about coupling. How many of you would describe your current systems as tightly coupled? Only 3 people. That's a very lucky audience, I might say. Good. So what does it really mean? Again, I have a tightly coupled system. When I was a junior developer, I was introduced to the concept of coupling, of tight coupling. And at that time, I kind of understood that it's bad and we shouldn't be doing that, but I haven't seen the long-term implications of that. And months after that, I realized that there are different kinds of couplings. We have common coupling, we have data coupling, we have external coupling, temporal coupling, logical coupling, spatial coupling, etc., etc. So just saying something is tightly coupled, it's like saying nothing. We have to go deeper and deeper and deeper again. So this feeling of something being tightly coupled in big ball of mud is mostly referred to when I have to change module A, module B, C, D, E have to be changed as well at the same time. So this is the structural coupling that we are going to cover today. And this is bad in our monolithic applications, this structural coupling. This necessity of changing one module when different modules, which doesn't have nothing to do with the first module, has to change as well. All right? And the implications of tightly coupled solution is that our code becomes hard to understand. So we skim through our code base, and every now and then there's a big fat if statement which has nothing to do with the current flow of the business, right? How many of you have seen that in your code base? Yeah, I have seen that too. So it makes it really hard to understand our code. It's called an accidental complexity. It's not essential complexity of the real business problem, it's the accidental complexity that we bring together with our solution. That's why it's hard to understand, because it's accidental, it's not essential. On top of that, it's hard to maintain, because every bug fix that we are going to solve might break something which is not related to the actual bug fix in a distant element of our system. Why? Because everything is tightly coupled. So we share information between distant elements of our systems. So it's hard to maintain. After all, it's hard to deliver value, because it all goes down to questions like how productive a new developer in our application is, how long does it take to actually estimate something, and how rough our estimations are, and does it take 6 or 7 months for a person to actually get to know what's going on inside the system. So it's hard to deliver value. And after all, our job as engineers is delivering value. So we justify that, and we say that, okay, something is hard to understand, and we have to refactor. How many of you would think that something which is not understandable has to be refactored? That's the only reason. Hands up. Like half of you. So I would like to share a quick story from my, let's say, previous life when I was a junior developer. And as a junior developer, I have read all of those books about clean code, about refactoring by Fowler, about working effectively with legacy code by Feathers, etc., etc. So I was kind of, I have to do that because that's my job as an engineer. I have to refactor all the time. And let's say that at this time, I was working on a system which didn't follow neither of those good guidelines from the books. If there was something which is completely opposite to the book, that was my system at that time. Like complete opposite. No Yagni, no kiss, don't repeat yourself, solid grasp, nothing. So my job as an engineer was to fix that, right? So I did my job. It took me 3 months. And after that I felt really lucky because I didn't get any merge configs after all, within 3 months. I was like, yay. But then I realized that it wasn't just coincidental because nobody cared about this part of the system. Nobody pushed anything. Nobody reported a bug request. Nobody reported a new feature. The system in this part did a job. Nobody cared about that. It was something about sending emails, sending text messages, sending postmail, etc., etc. So it took like 2 days to actually understand what's underneath in the system, but nobody needed to understand that because there were no feature requests. And 3 weeks after my refactoring, they bought a new system for communication. So actually they replaced my new shiny model, which was refactored. But I learned something. We have to justify refactoring with business value. So clean code is not enough, right? Maybe it's a temporal code. Maybe you are doing an experiment, so the code might be bad in production. Maybe it's just for 2 weeks. Maybe you are handling like a Black Friday or something like that, and it has to be there in 2 weeks. So the fact that something looks bad, it's not enough. our job as engineers is bringing value, not satisfying our aesthetic needs, I would say. So the conclusion is that we have to measure if the sloppy code with no structure requires rewriting. How many people read that code? What's the business value behind that code? How many times it has changed past year? All right? Refactoring needs to be treated as an investment. An important property of an investment is return of the investment. And what is refactoring anyways? Now we know when to refactor, but what is refactoring? How would we describe refactoring? How many of you think it's just a rewrite? No one. How many think it's like changing the aesthetics? Few people, all right. How many of you think it's like following Yagni, Kiss, don't repeat yourself, grass, etc., etc., all of the good design practices? So I think about refactoring like this. I found a great definition in working effectively with legacy code, and it says, code refactoring is the process of restructuring existing computer code. So changing the factoring, but without changing its observable behaviors. I cannot stress that enough. So we change the factoring, but we don't change the observable behaviors of our system. And that's crucial. So it means that if we don't change any observable behaviors, nobody is going to see the difference, right? Nobody's going to pay for that. If there's no change, how am I going to justify refactoring? How many of you have failed while trying to convince stakeholders to give refactoring a green light? Yeah, half of you. I have failed too, several times. And I would like to share some tricks from the battlefield, okay? So how to talk about refactoring with business owners, with business stakeholders. First thing first, don't say refactoring, never. Like, don't use that word. You cannot say that out loud. It's forbidden. It doesn't really exist. Why? Because you say refactoring, what they hear is fun, procrastination, and CV-driven development. I'm not going to pay for your new shiny Kafka, right? And they have a right to do so. So don't say refactoring. It's forbidden. We never say that word out loud in front of business stakeholders. Instead of that, create a common understanding. A common understanding when we actually create a safe environment in which we can have a common understanding of current problems in our system. For instance, you can do it with event storming session. Event storming session is a collaborative session in which you actually gather business owners and developers, etc., and you talk about your business processes using domain events. And there is a special notation for hotspots, which is a ping node. And on the ping nodes, you can have problems which are very crucial to your current business process. After this kind of a session, you have a common understanding of the current process, you have a common understanding of the flows, and where are the most number of hotspots. And if you have that, you have the first thing to refactor. So you don't refactor the whole system, you refactor where you find problems, where is business opportunity that might be really lost, all right? So you have the common understanding, but that's not enough. You have to use measurable data. So business people, they love data, they love numbers, right? They use things like Microsoft Excel. So they really like numbers. So we have to give them numbers. We have to justify things with numbers, with money. So what does it really mean? It takes ages. Let's say we have to justify refactoring a web page for call center agents because it opens up and renders 10 seconds. So if we say that we have 10 agents and all of them have to do that 20 or 200 times a day. So roughly counting, each of them loses half an hour a day. Let's say if we have 10 agents or 12 agents, roughly counting, in overall, we lose 6 hours per day. If we fix that, you might get a new person for free to hire, right? Because you're losing money. That's the kind of data, hard data, that really gets to them. And you know you did a fine job justifying refactoring when business people, when business stakeholders, when they get mad, really. Because after this kind of justification, their reaction might be, what the hell? Why haven't you told me that before? Let's do this your thing, or refactoring or something like that. So hard data is really, really important. I tried to convince you before, but I have used different language. I was talking about refactoring, etc., etc. And now I'm talking about certain numbers that really get to you. if on top of using measurable data and creating a common understanding, it still doesn't work, tell them you're going to use magic. Because they might be really not convinced because of the fact that in the previous solutions, they agreed to refactoring and the system behaved worse than it used to behave before refactoring. And that's why they are not convinced right now. So tell them this time is going to be different. We are going to use magic and we'll give them a magic button. And the magic button is shiny, by the way. So if the magic button is shiny, you can give them access to this shiny button and they can revert to the previous solution in no time without having to call you, without redeployment. So the reaction might be, you're saying it's totally safe, I can go there, have control and click it, and the system would behave like it used to behave before your fancy refactoring. Yes, that's what you can do. So this might be convincible, and one thing to remember, we cannot talk about refactoring as a feature. It's really hard to talk about refactoring as a feature because while refactoring, we are not adding business features. We create refactoring, we create a safe environment for the new features. So you might want to do that step by step. First refactor and then create another new feature, because doing two things at the same time might cause problems and might effectively slow you down. If you want to talk about features, we might call it like a feature that enables you to deliver subsequent features faster, quicker. It's a feature that you might say that improves your quality attributes of your application. All right, so we know what refactoring is about, how to talk about refactoring and when to refactor, but how to do that. So from this moment on, we are going to represent our current system with this brown emoji and our current or desired solution with this unicorn. So we have two states. We have the current state, which is big ball of mud, and we have the desired state. So in the desired state, we follow all of the good design practices that are applicable in our solution, like maybe TDD, maybe actor model, maybe functional programming, whatever fits the problem, all right? And we have to make the transition, keeping in mind that the desirable observable effects has to be the same in both solutions. And also the new unicorn is clean and shiny for new requirements. So how to do that? How to do that if there are no tests, right? How many of you would describe your current system as not tested? So how to refactor, how I'm going to make sure that I'm not changing the observable behaviors if there are no tests, right? So good news is that observable behaviors, they can be expressed as automated test scenarios, almost always. It depends on the actual technology you have underneath, but it can be done. It can be done. Whatever you use, it can be done. It might be problematic, it might be really painful, but at the end of the day, it can be done and it must be done. Because without that, we are not making progress. We cannot be sure that our observable behaviors will be kept. How many of you have heard about the healthy testing pyramid? So in a nutshell, it says that at the bottom you have a huge amount of unit tests, which test all of the business rules that you might have, which gives you fail-fast scenario and feedback. And then on top of that, some units have to be integrated with each other. So you create a sort of integration test. And then on top of that, you have for crucial production bugs and crucial production paths, end-to-end test scenarios. So it says that we have to have a huge amount of unit tests, right? How I'm going to find units in big ball of mud? What's the unit of big ball of mud? The problem with big ball of mud is that when you want to isolate some unit, there is like 6 or 7 or 70 more units to go, right? You reach for the banana and you get the entire gorilla. So it's really hard to test. How I'm going to find units in big ball of mud? It's really hard. I don't want to go inside and dig and find actually some units in there. So the only way to test big ball of mud architecture is to test it from the boundary, right? So you have to treat the big ball of mud as the huge unit that you would like to treat as a whole, because everything inside is tightly coupled. After all, if it was easy to find units in big ball of mud, it wouldn't have been big ball of mud in the first place, by definition. So the only way to test big ball of mud is to test it from the boundary, which means we are not going to have a healthy testing pyramid, we are going to have something like that for a while, for the transition period of refactoring, right? we'll create a safe environment for our refactoring when we change our model, but will be backed by those end-to-end tests from the boundary. That's the only way to go. But how to find the scenarios? Luckily enough, if you have done your job while talking to business people, you have the scenarios. For instance, you can do it with event storming as well. So if you go further with the notation of event storming, there are more colors of your sticky notes. For instance, you have a domain event, which was already covered. We have a command, which is I'm colorblind, by the way, but I know the colors by heart. Command is a blue note, and then you have a query, which is a green note, and then you have rule, which is yellow, all right? So let's say we found our hotspots in our application which deals with lending books, and the process of lending is actually something we would like to replace with our new model. So we would like to refactor the lending process of our application. So we have all of the behaviors found during the event storming session, and now it's crucial to notice one fact. Our users, they interact with our application in two different ways. They either send a command or they ask our system to give them some information. So it's either a command or a query. And notice the fact that we are not going to talk about a specific technology that we interact with our application, but I'm going to talk about the interaction, the intention of our user. Either do something or give me some information. So if you have that, it might be that a command is something like API call, it might be a queue listener, it might be a database script being executed, and the same with query. It might be API call, might be some database query, etc., etc. If you have that, now you can automate that in your testing tool. Whatever you use, it doesn't really matter. How many of you use Spock, by the way? JUnit? TestNG? All right, it doesn't really matter, just I was curious. So you have the tests which speak the domain language. They don't expose the implementation details about how we are interacting with our system. If it's a REST API, if it's a SOAP API or something really else, it doesn't really matter. And the observable behaviors are in here. So if the patron wants to hold a book, which is a command sent to our big ball of math, then if you do a subsequent behavior, so you ask for the book placed on hold, you get the current result. So you write those kind of tests. These are end-to-end tests, you might say, and you create your safe environment. A good question is, what if I don't have access to domain experts, or I have limited access to domain experts? What do I do then? In this kind of scenarios, you might do exploration testing against your present data sets. So it might be that in your organization, you have access to obfuscated production copy, for instance. So you can run some tests and explore what's going on inside. How would it look like? You create a test, right? So you find, for instance, in your database, a book, domain-driven design. You have a patron which is going to hold and place on hold books. Amy and John, what do? You try to place on hold domain-driven design by John, and you get an exception. Why? We don't know yet, but we want to make sure that it's going to happen in the subsequent invocations of our test, so we assert, right? And then you do the same with Amy. In the case of Amy, you have a success. Why? We have no idea right now. But you want to assert that the success is going to be present in the subsequent invocations of our test too. And then you get to ask questions. What was wrong with Amy? What was wrong with John? How the ADD is special? Why is so? And now you can go to business owners and actually ask some questions because you have more knowledge. So you do exploration testing, especially if you have 3 days in an organization because you have to understand what's going on as a consultant, then sometimes it's the only way to go. All right, so now we have our safe net. We have our end-to-end test scenarios from the outside of our application, right? But now we have to do the nitty-gritty details about transitioning from the big ball of math to our unicorn. So how we are going to make the transition? How we are going to make sure that the old model will turn to the new model? So I can see at least 2 solutions to do so. So you either do something which I call step-by-step refactoring. So you every now and then extract method, extract function, extract object. You put your classes into a testing harness. You create smaller dependencies, etc., etc., etc. And your big ball of math, your landing process in big ball of math slowly becomes the unicorn after 2 or 3 years, right? It might be so. The other option is something which I call Bluegreen refactoring. It's not Bluegreen deployment, by the way. And it is where you create a safe new model alongside the old model. So let's start with the step-by-step refactoring. If you would like to do that, again, the same book that we already mentioned like 4 times, working effectively with legacy code. So in this place, your big ball of mud slowly becomes the unicorn, right? So the observable behaviors are kept because you are dealing with one model. You have the safety net around your boundaries in the form of unit end-to-end tests. But the thing is, it's not easy to go back from the unicorn to the mud halfway through. You might be introducing some bugs, right? That's probably likely to happen if you do huge refactoring. And if you just change your code, it's really hard to go back, especially if the migration happened with some data migrations in the database. But the good thing is that you need to maintain one model at the same time. But you need to dig in the mud, which is not pleasant. So from my experience working with teams, this kind of refactoring doesn't work when the distance between the old solution and the new solution is so far away that you actually cannot see the end, right? In this place, from my experience, they end the job half the way. So you don't have the unicorn, but you don't have the mud, or the mud is like colored. You have something which is done halfway and looks like that, right? It's a little bit better than the big ball of mud, but it's not the unicorn, right? So it takes patience, it takes determination, it takes skills to actually go from something which is so far away from the ideal solution. So this is when I recommend the second technique called Bluegreen refactoring. In this place, you don't touch the mud, the landing process stays as it was. You create a new model for landing process, which is a unicorn, inside the same application. So the observable behaviors will be kept. It's easy to roll back from the unicorn to the mud because you don't touch the mud, right? It's still there. You haven't touched anything. Doing this unicorn in a brown field feels like a green field, right? Because you get to start from scratch, and that's good. Also, the problem is that you need to maintain both solutions at the same time. So if it takes 3 months, for instance, there is a huge likelihood you will get a new feature request to the landing process that have to be mirrored in the same models, right? That's the drawback of this application. The thing is that, from my experience, safe refactoring, safe changing of your model, the key strategy is running the old design and the new design at the same time. Because this is why you create the refactoring which is safe. So how will it look like from the structure of your models? You can start by doing a new model for your new model. So you have the big ball of mud, and the unicorn is fully isolated. But the thing is, if I finish, how I'm going to plug in the new behaviors to the new model, right? Because the behaviors, they used to work against the old model, right? For instance, our automated tests. And again, to help us with that, again, Michael C. Fathers comes with a rescue. You can find a seam in your code. What is a seam? He describes seams as places where you can alter your program without editing in that place. So think about injecting a mock in your test. You don't change the program, but you change the behavior. So we can do the same in here. So we have to find places in our application which are candidates for seams. For instance, our users, let's say they integrate with us, they interact with us using REST API. So you have a command for placing on hold your book, you have a query for getting the information about already placed on hold books, and you have to modify it there. That's your seam. Let's start with the second one, with a query. It's easier. So when it comes to query, you might want to use something which I call anti-corruption layer. What is anti-corruption layer? It's the only place in your whole system which gets to know there is something like an old model and new model. That's the only place which has this knowledge. Everyone else just knows there is a landing process, and ACL knows about the old model and new model. So when it comes to query, you just want to plug in the ACL at the end of the current query execution. So the last line of the code, as you can see. So how it's going to look like from the big picture? You have two models. We have a query, and you either ask the old model, right? Go to the database, or you ask the new model. It doesn't make sense to ask two information at the same time, right? You want to return a single answer to your user. And this is where magic comes into play. Because you can use feature toggles. That's the shiny magic button, right? You can either go to the old model and you can use the new model if you want to do so. How many of you have heard about feature toggles? You can treat them as dynamic if statements that can be changed in the runtime by changing some information in the database or via user interface, for instance. You have plenty of libraries to do that, so you can choose one of them. So let's take a look one more time at the anti-collapsion layer when it comes to querying. Because inside of the ACL, you just do the if statement, which can be dynamically changed by the business owner, and you either go to the old model or you go to the new model. So that's why we make it safely, all right? How about command? The command is something different because at the same time you want to change two models because they need to be synchronized, right? So regardless of the setting of your feature toggle, you want to modify two places at the same time. So again, at the end of the current command execution, you add a line through ACL which deals with the new model when it comes to your landing process. On the landscape, it looks like this. You change both places at the same time. So you change the old model and you change the new model. So if you use a new data model in your database, probably ACID transactions are your friends, but be careful with that because the new model command failure shouldn't affect the old model result. That would change the observable behavior, right? That would be against the definition of refactoring. So a simple design for failure in the form of try, catch, and log might be your friend too. So when it comes to structures of your models, ACL might be a third model. So we have big ball of math, we have the new model, and you have the ACL. And the dependencies between those models, they look like this. You have the whole application, the big ball of math, which talks to the ACL when it comes to landing, and landing routes through old landing design and the new landing model. Whatever you have set right now by the feature toggle. And now we have to do, and we can do, and we get to do something really useful. You can reconcile two models in the ACL. Previously, I lied to you because actually you work in three modes. The first mode is just using the old model as it was. The system used to behave like it used to behave. So two toggles are disabled. And then you can also have just reconciliation enabled, but you still use the old model. So from the outside, the system behaves like it used to behave, but in the background, you run the new model as well. And you reconcile them. You check if they are matched or not. So this is why I love legacy systems, because you can mitigate the power and the knowledge of legacy systems. You can actually test in production safely, right? You can use the power of the if, nitty-gritty if statement in your application to make sure your new shiny model works correctly. There is no better way of testing your new model than testing with the current data, current users on production. But you can do it safely. It's in the background. You can reconcile, and you react if something works badly. So this is almost exactly the code I have used with one of my clients. Almost. We haven't used system.out.println, but instead of that, everything was copy-pasted. So this is this amount of code you need to reconcile two models. If there is a difference, you want to react to your difference. And you can be very, very, very creative when it comes to the reaction of your difference. For instance, you might want to log it in a separate file for logs, or maybe you want to send an email. It might be that in your organization it's a strategic refactoring, right? So there will be people interested in that. So you want to send them batch emails, maybe? Or you can do a composite reaction. You can do three things at the same time. For instance, you can also automatically disable the toggle so that the system goes back to the previous solution. And it feels like a self-healing system, right? If there is a difference, I'm going to switch back, fall back to the old solution without having to change it manually. So you can be very creative and you can do whatever you like in the reaction. So with Bluegreen refactoring, when you have like a new model and the old model at the same time, and you can run them in parallel, you work in a cycle. You start with a new model, you find the new theme, and you create a new function in the new model for the first business function you want to refactor. And you go to prod. You reconcile in the background, and you use the old model as the observable result for your user, so that the system is not affected. But you gather feedback, right? You gather feedback. At some point, there is no more feedback to correct, so you turn on the new model. After 2 hours, someone will call you, hey, it doesn't work. All right. Imagine a safe environment when you can actually, on Friday, disable that and fix that bug on Monday. That's very safe, right? That's very calm. So with this design, you can do that. You can switch back to the old design and fix it on Monday, and then go do the same one more time. So you go through the cycle one more time. You go to prod, then again, gather feedback with your fix, enable the toggle, and use the new model, and you wait for the first call. This time is going to happen after 4 hours, etc., etc., etc. At some point, you are ready to use the new model. But there's one problem, because those tests that we have run, those tests that we have written before, they have worked against the old model. How we are going to make sure the tests are going to pass through the new model as well? We have to change them somehow, right? So luckily enough, all of the mature libraries when it comes to feature toggles, they allow you to modify the toggle in the test itself. So this is this amount of code you need to make sure that the tests are passing against the new model as well. That's it. That's the first line of code when it comes to JUnit and this specific library. So all of the mature libraries when it comes to feature toggles, they allow you to change the toggle dynamically, programmatically during the invocation of your test, and that's good. But we have to do something with our testing pyramid, right? Because we have a huge amount of end-to-end tests. They are slow, they are brittle. We have to fix that. But if we designed our application, our new model, according to good design practices, the new model has all of the unit tests that it needs, right? So all of the business rules that we have, they are tested in the new model at the unit level. Which means for some period of time, we have tests in the unit level of the new model and the end-to-end level of the whole application, right? So they are duplicated, you might say. So at some point, you want to just remove them and fix your testing pyramid, right? When you are sure you can actually remove the end-to-end to test, you are going to save some of those probably for crucial production paths, and all of the business rules now are tested at the unit level. So this is how we give back our healthy shape of our testing pyramid, all right? Which means that when you are sure, after 2 months or 3 months, depending on the organization, you can delete the old model. So you can also delete the reconciliation, you delete the path from the user to the old model, and you can delete the dependencies between modules as well. So previously it looked like this, now it's going to look like that, all right? So we have the big ball of math, and now there is a new landing model. ACL is gone, the old landing model is gone as well. And this is how we create this bubble from our big ball of math. This is why it's called a bubble context. It emerged from your application. One thing I would like to mention, because that's a frequently asked question. Why not going with microservices with that? Like, why not creating a fresh microservice for the new landing context? That's a question that's really frequently asked. So I try to answer this question using this chart. If you classify your systems according to 2 classifications, first of them is your system distributed? And the second one, is your system modular? What does it mean my system is distributed? It means that for the entire system, I need a separate number and multiple number of separate deployment units, right? So if I want my system to operate and to deliver business value, I need to deploy 4 or 6 deployment units, right? That's a system which is distributed. And then I can also ask if it's my system modular, which means, do I have a tight coupling when it comes to this structural coupling, or do I have a nicely decoupled, highly cohesive business modules inside of my application? Doesn't really matter if it's distributed or not, all right? And then I can have at least 4 situations. The first one, which is neither modular and nor distributed, that's a big ball of mud. That's where we are, and we don't want to be there. That's what most people refer when they say monolith. Monolith is not bad by nature. This monolith is bad, which is not modular, right? So we have big ball of mud, but we can make it worse. We can have our not modular system, which is big ball of mud, and we can make it distributed, and we now have distributed big ball of mud, right? Which is even worse. So I call this place a place when you manage to have all of the problems with microservices without having a single benefit. That's a distributed big ball of mud. It's even worse. It's like multiple pieces of shit instead of one, right? And then you can also have something which is not distributed, but it is modular. And we call it a modular monolith. I also call it a majestic monolith, structured monolith, which is good. And then we have a system which is both modular and distributed, and we call it microservices, right? So most of us are here, big ball of mud, and we want to be at the microservices level because that's what our industry tells us to do so. But the path from big ball of mud to microservices, it goes through here. Why? Because you fix one problem at a time. You don't want to fix problems with technical problems with microservices and modularity problems with your entanglements and your coupling at the same time. It's harder and it's slower. So the path goes through here. But people like to take shortcuts and they want to go from big ball of mud to microservices. But the problem is that most of them end up in here. So this is why I strongly recommend first to fix your modularity, your coupling, and create a highly cohesive set of business models. And then if you really need to do so, if there are architectural drivers like independent scalability, then you can go with microservices with your new fresh context, like our new landing model. It's going to be easier, all right? Lesson learned from the battlefield. Always, I cannot stress that enough, always test if your ACL works correctly, depending on the feature toggle settings. That sounds like a really simple test. If the toggle is set to true, go to here. If not, go to here with mocks. That's a really simple test. Trust me, it's going to save you some not so pleasant calls during night. Also, go to production and reconcile very quickly, which means after finding your first theme, after creating a new function with your new model, go to production. Of course, don't enable the toggle, use it in the background as the reconciliation mechanism, but just do it so that you gather feedback. It's going to create a safe environment for the subsequent themes and subsequent functions in your application. With that, I'm going to thank you. That was my first talk that I did without live coding ever. So if you like live coding and you are like me, that without code it doesn't really work. So there is a link with the whole process. If you would like to take a look, it's actually with Git tags, so you can see each step of your process, like old model, new model, introducing ACL, introducing end-to-end test, etc., removing end-to-end test, blah 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 blah. It's all in this repo if you are interested. I'm here like for the next 20 minutes. If you have any questions, I'm happy to answer those questions. And I wish you a great presentation, next presentation, which is going to be about tests, right? And a very happy day. Thank you.